Hi everyone, I'm Xiu Xuan. I still couldn't resist the temptation to make a video about what I learned during this semester. And in this video, I'll start with CS2103T software engineering from NUS. I'll basically cover what I've learned and my thoughts on some of the things that I've learned. Um, to give my conclusion first, I hate this module. I think that it basically doesn't teach me anything. That said, I'm going to address some of the topics covered in this module and my thoughts on these topics. The first one that I'm going to talk about is OOP. Um, oops. Um, the first one I'm going to talk about is OOP, Object-Oriented Programming. And I think one of the things that this module does poorly is that it makes you believe that OOP is a way of doing things. Despite the prof clearly said in the notes that OOP is not a way to do things, this module only teaches you how to do things in OOP. And that's pretty bad because um, I think there are lots of problems with the OOP that the industry is actually talking about. I'm going to basically address several of them that I've learned this semester. It was basically while I was exploring on my own. The first issue with OOP is inheritance. Okay, I'm going to do this. The issue with inheritance is that compared to other the issue with inheritance is that basically what it allows is that it allows the child class to inherit um, inherit how to pronounce it, whatever. Basically allows the child class to inherit the state of the parent class, and the result of this is that it basically gives you a lot of coupling between the child class and parent class. Thus, it makes it very difficult for you to change the code later on. And I think this is not really covered in the class. I'm not sure. I never attended lectures, but I believe that a lot of students also don't attend lectures. Since Prof said it's okay not to attend lectures, but I feel that mm, uh, the fact that this module doesn't really give um, this coverage on how bad inheritance um, is is pretty bad. Yeah. Um, Instead, compared to inheritance, what we should favor is composition. One thing that you may be really surprised is that if you've just taken this module, is that everything that can be done with inheritance can actually be done with composition. And more specifically, it's done with composition plus polymorphism. Well, you may say that isn't polymorphism a thing with with classes? It was done by inheritance. Well, no. Essentially, we can achieve polymorphism by defining interface and implementing interfaces. Let me just change the formatting of this here first. So um, because I was doing Flutter development before I take this module, initially I was quite troubled that in the Flutter widget systems, you cannot really inherit a widget and make it say you cannot inheritance in the widget system is not really encouraged in Flutter, and instead was encouraged you to do composition. But later on, I realized you can just use composition to build widgets just like as you done in inherit. So essentially, if you think about it, right, as I said before, inheritance gives you two things. The first is the first is that the child class will inherit the state, the fields of the parent class. Sorry. And the second is that the child class will inherit the behavior or the methods of the parent class. Now, if you were to actually extract those shared behavior and you put them into a separate class, you can use basically a redirection of methods to achieve that. So, for example, let's just say Java. If we have a class animal, and if you have a method, one way of doing things is that we can actually how to put it one way of doing things is that we can make this class abstract. And let me think about like what to actually put here. And we'll have another class dog that extends animal, right? And oops, I don't know why my Vim is not working very fine. And when we let's say that that's the class animal has a say let's say that class animal has a method called walking, right? So it's public void walk. Um, and what walk does is that it prints that animal is walking. One way of doing this is that we can try to override in the child class. We can just like extend this in the child class, and basically we'll have like dog is walking in the child class. But the other way is that maybe, just maybe, like if we were try to achieve the same feature, right? Another way that if we were to use inheritance, or like say use composition as opposed to inheritance, probably we can define a class called worker. And what worker does is that a worker takes in a function called and basically I'll just like string name, and what it does is that will print out wait, how do Java actually, anyways, name class is walking. I don't like this plus thing, but regardless, let's just do it this way. Essentially, you have two ways. The first way is that you use stock to extend animal, and you try to override. Let me just write it. Let's just get the font a bit smaller so that you can see the full picture. I think the override O in Java is capitalized. Override public void walk, right? And then you'll have y. Basically, dog is working, right? This is one way of doing things. And the other way of doing things that you may think of is class dog. And maybe like you also have an interface called walkable. And with walkable, you'll have basically right. And another way of doing things is that you can let the dog class implement the walkable interface. And with the walkable interface, right, you'll have to also override, and you'll basically provide a implementation that basically public void walk, right, of the parent method. And inside it, right, you want to probably like store like the worker instance, the worker class as a private instance. So private final worker. And when you construct that, you can just like call this worker.work. Wait, I don't even recognize how this works. Okay, never mind. Dog. Right. So this is the alternative way of doing things. Basically, you can extract. I don't know how to spell today. Extract the feature into a extract the implementation of a specific and what this does is that it basically does things in a compositive way, as opposed to a sort of as opposed to a what? As opposed to inheritance. Now this example may not be very nice. Let's just modify this example a bit. So I think I'll get my point across a little bit better. So basically, in the parent class, we want to know like the type, right? So public string type. Basically, I want to know what type this thing is, and since this will be abstract, no, let's just not make it abstract, and let's just say return animal, right? And inside here we can change this into type self.type. Sorry, in Java it's this or self. Oh, Java I think it should be this dot type plus is working. So wait, which one do we use? Regardless, we'll just keep it using this, whatever. I kind of forget a bit about this. So basically, inside the child class now, instead of overriding, instead of like in the first way, instead of overriding the work, right? What we want to do is that we want to override the type. And what we do here is that we return we return a string type, and want to return dog, right? Basically now the dog class will be able to print when you call work on dog, it will be able to print print the print dog is working, right? For sake of convenience, let's just let me just move this in D8. Let me just move this down here, and I think this is still too big to see the full picture. So basically, for the parent class animal, right? It requires a child class to provide a type, and if child class doesn't provide a type, it defaults to animal, and will print using this type called type is working. And we have a child class called animal. Sorry, we have a child class called we have a child class called dog, and that overrides this type method, then provides a dog. Therefore, in the parent class in the work, we have dog is working. And the alternative way is that we can define a probably like a utility class just outside here for now, and we'll call it worker. And instead of taking and we'll define another interface called what? We'll just also use animal, because animals will have a type, right? So this may not be a very good idea, but let's just do it this way. We'll have an animal, and basically this will basically take an animal, and it will take any animal, and it will print out the animal is actually working. Now inside this worker, right, we'll just basically say work this. Basically now the dog will be able to walk, and when you call walk, you are basically passing this. And it may not be very obvious because I put the walk inside the dog things, but actually like you can use like a similar thing like whenever you're outside. Basically what this does is that if we are using interfaces as opposed to inheritance, we are basically trying to define a boundary that's between how to put it, define an abstraction boundary through the interface, and anything that below the interface workable, or below the interface and implement and animal, anything that's below the interface animal, let's just remove this because this isn't really necessary for my purpose. Anything that's beyond the interface animal, which we don't care, and using this type, we'll be able to work this type. So you define this boundary and put a shared application logic. Instead of putting it inside the class, it moves it outside of the class to a separate entity. Here we use worker, but maybe something else. So what this does is that the shared code would not need to be shared, at least like methods, they will not need to be shared in a parent class. They can be shared in an external party. And for you, like when you read the work code, it's very like obvious for you that the animal is actually like so you basically print out the animal's type and plus working. And when you read the dog code, basically it implements animal. Sorry, I should provide a type and return dog. And sorry, like this is a bit messy because I just came up with this example on the go. But like when you read the animal, right? It also like provides this type, and which also makes perfect sense. So in this sense, we try to like, but think about like the other case of this animal case, right? We have an abstract class and we have a string type and a work. And the thing is, you often have to think about like how to put it, this is an example with only like methods, right, with only methods, yeah. But when we like actually read about this like thing, if we provide a default implementation here, right, what will end up happening is that we may end up with like animal is working too, and in the child class we extend the parent class. But if we don't really read through the code of the parent class, it may not be immediately obvious with what things that we have to provide, and this may cause like sometimes you want to print dog is working, but what you end up with is animal is working because you forget to override type. This may be one of the issue, and this issue becomes like more like significant if you try to use like a shared state, say like private string say final, and we'll return this. I don't know if in Java you can name a variable and a let's just say in the typical Java boring way of writing getters. The thing is, I was too lazy to like open several Java files, but I kind of regret it because I couldn't use like my famous refactoring for that. And it becomes more troublesome if you have some hidden internal states. And for the child class, you have to either call a constructor to the super, and which makes you like to set the type, or you have to override this. But this thing cannot be override. Maybe like it's protected. And protected, right? It breaks a lot of like the abstraction boundaries because yeah. And as a result, I think that maybe I didn't present this very clearly, but I think that inheritance is just like the wrong way to go. So that's one of the first things I've learned is about OOP and why I think it's bad. And there are also like, because this CS2103T is so pragmatic about OOP, like in the TP code base, basically the team project code base that they provide you with you, they have done some insane level of abstractions that I feel that are just merely not necessary. For example, if I remember clearly, they even had a class for name that basically just holds a string name. So if I remember correctly, because I couldn't really remember, I just deleted that code because I felt like it's just too much abstraction. If you're like, what is the point of even using a class for a name? I don't feel that. So I feel like that's the first issue with this module is that it's too much emphasis on the object-oriented ways of doing things. And object-oriented programming is, in a sense, in certain sense, very nice, especially if you're dealing with like UI, as from what I've heard, and I've been very familiar with Flutter, but Flutter also uses a very nice object-oriented system. But at the same time, I have to say that you have to like teach a lot of things that are not so good about object-oriented programming. Those things are much more valuable than other things taught at the module, which leads me to the second point about UML. like when I was joking to my friends, I call this unbearingly boring, mundane, because like it, it doesn't really solve any problem. Um, when I started thinking about UML, I thought about like there are two potential use cases. The first use case is in design, is like when you try to design a like a UML, design a software that basically like you use UML class diagram to draw like a class A inheritance from class B, which is bad. You don't need that. And the other thing that I think about when I think about UML is that it could possibly be in communication. Uh, or let's just put it in this way: documentation. I don't find any other use cases of UML other than these two. But the problem is that with design, right? If you just sit there and write a UML code, I feel like you're not going to get a working design. I feel like oftentimes it's more intuitive just get into the code and write the code to design. Because like the moment that you start writing the code and you encounter a lot of issues that you didn't think before, and sometimes it requires a lot of refactoring to get the code right. If you just sit there and think, oh, this thing should have one of that and one of that, it's actually like not going to help you with the design. And it also makes it a little bit troublesome later on as you try to implement that design in your code. And what ended up happening is that like your code may be drastically different from the UML design that you initially come up with. And this leads me to the problem with documentation. Essentially, like it's very easy for you to get out of sync with from your documentation to your like actual code base. Sure, there are automated code base automated tools for that for generating UML. But if you're actually using automated tools for generating UML as documentation, why should you ever learn UML, right? It doesn't serve a purpose. And I believe that a lot of the companies they don't use like UML, at least from what I've heard. Um, and let's face it, like the problem that UML is trying to solve is real. It's communication. Because oftentimes, if you do things, you'll realize that like what you want to do is drastically different with like what your boss wants you to do, or like what other people like what's like what you want your team member to do is actually from different from what he or she ended up doing. For example, in our team project, I had this idea of like a link. Basically, a link describes a one-to-many relationship, and I wrote a class for that, encapsulating some of the intricacies in that. And in this case, like multiplicity, navigability becomes a problem because like where do you store the link? If you store the link um, in both objects, it will be sort of difficult to keep both in sync. So you have to store the link in a way that's like that makes sense, makes intuitive sense. And I thought it was like actually quite logical. And but I just handed out to one of my teammates. But like the result is that he got it wrong, right? He stored the link in a wrong location, in a wrong class than the class that I intended to be. So that made me realize that for real, like if we actually wrote a UML diagram while I designed that, then that may have possibly solved the issue. But I feel like the problem with UML is that it has this notion, this intuition of like um, communicate once and then everything is done. So basically you have this, it is designed for, because it is so standardized, right? It is designed for this notion of like you communicate once, you write one diagram, then everyone can be on the same page, and then everyone head off to do their work. And then after a long while, they go back and they merge together and everything works fine. This is the premise of UML. Basically, it tries to provide a standard way of communication that leaves no room for error on the developer side. But that is not how communication should be done, I feel. Right? I think that communication or like code development should be done in a like sort of like continuous fashion. It's like the CI, CD something ish. Basically, communication should happen on a day-to-day basis. If like I saw the person's code base went wrong, right, and we do it in very small increments, then I could just correct it, and it wouldn't hurt much for us to make that mistake. But we could just like keep communicating and keep getting the thing geared to the direction I want it to be. The which defies any purpose for the existence of UML. If you were to like separate tasks into small subsets of tasks, and you're not going to communicate for the next 6 months where you each work on each individual part, then sure, UML may have its place, but that's not how I feel currently the software designing system works. Next, I feel like one of the most useful things that I've learned from this module is the use of debugger, because to be frank, I'm a Vim guy, and I don't often use debuggers. The idea of like it just makes me feel that having a debugger is kind of convenient at times, because you can see where like the problem went wrong and you can jump around in the code base, and that's actually quite cool. And the debugger also has like a lot of fancy features that in some of the tutorials they're covered. But then just recently I've also learned this thing called like logging, which also this module talks about. But I've also encountered this in my 2109S final project. I guess I'll talk about it in my review for that module. And basically, I just log out the important, like logged the important steps in each way. And I could, like through a search, each time I run the program to easily find out what problem was going on. And I find that having a powerful logging system makes like debugger really not that necessary. And oftentimes, like with debugger, I don't know, maybe it's that I don't really know how to use it. I find it like I have to jump around quite a few times to get the thing right. Right. So maybe it's because I'm not familiar with it, but I find debugger to be something helpful. Still, because I feel like IntelliJ IDEA is just too much like janky, a bloatware, something. Yeah, and I don't feel comfortable using. I don't feel comfortable using the community version because like it just feel like cheap. I don't know. And I don't really feel like paying for IDEA after my graduation. So I'll stick to Vim, and I probably won't use debugger, but I find it to be a pretty helpful tool. The other thing is a very trivial point is a static extension method. So because I came from the Dart programming language, and in Dart there is this thing called extension. So basically, say if you have a class, let's say a class point, right? And point stores two things, which is a double x, which is in the x location, and double y, which is the x location of the point. And you realize that this point class defined by someone else does not provide this feature called distance to, which calculates the distance from this class. So in Dart, you can have this extension, keyword, and you can call point x means extension on point. So you create this extension on point, and what you do is that you can write a function here. So basically, double distance to point p. This is the other. I seriously couldn't remember which one is using this, which one is using self. But anyways, so you just return this dot math.sqrt, basically like this dot wait, how do you calculate? Okay, so it's this dot x minus other dot x times this dot x minus other dot x. This is getting way too long, so let x to x squared equals yeah, let y squared equals minus times. You get the point, but I just feel like typing everything out. So basically x squared plus y squared. Hopefully I didn't get this wrong, but whatever. Basically, you have this, and what you do is that in code you can just see point p equals point. Let's just assume, because I didn't write the constructor 2, right? And point p. Let's call this p1, and p2 equals point 13. I'm not going to calculate the trigonometry. Okay, and then like what you can do is that you can just simply call p1 dot distance to p2, and it will basically return you with 1, right? This is the static extension. Basically, using static extension methods, you can add this distance to, right, to the point method, and as if it were defined in the class itself, as if you just didn't have, like, say, if you didn't have this and you have this over here, but this is like what we call static extension in Dart. And when I first encountered this, when I was writing like the TP code, I just really miss this extension method. But then I realized, for a long time I thought it was necessary for me to use this method to write code. But then I just realized actually it wasn't really necessary. So essentially, this static extension method is equivalent to just defining a double distance and point this, point other, and you just basically do the same thing, right? You get what it means, right? And then you can simply call distance this other, and what basically gives you the distance. What the reason basically, like, this is just a syntactic sugar that I didn't realize. And afterwards I just saw this online, and called the Dart, like the extension feature. And basically, it also describes the same thing that I didn't see before. And this was quite interesting to me. Basically, it makes the code more readable, but it isn't like as an important deal as I thought it was. And you can also clearly see why this is static, because this distance method doesn't really actually originally belong to the point. It was a static method. It is just as if you pass this point, as if it was like an instance method of the point. So it's a static extension method, and it's actually something quite cool that I figured out while I was coding. Lastly, I'm going to talk about what I think this module could be better. Because if you follow through like for such a long time, me boringly talking about this stuff, you realize that I don't really learn much from this module. Because I feel like a lot of things taught in this module are not really worth learning, and therefore, therefore I don't feel like I learned much. And most of the things I learned were basically through self-exploration, when I'm like exploring on my own. So I feel like this module could be better if it talks about like basically inheritance and how it's bad, right? If we could spend more time talk about the different programming paradigms, yeah, I feel like that could make like software engineering much more interesting. And I feel like it could talk about the what? One sec. Design patterns. Granted, some design patterns were briefly talked about in the class, basically singleton, command, and facade. But I feel like there are much more like design patterns and good code practices that could be covered in this class. And this is much more important than the programming paradigms. For example, and you also could talk about something related to software architecture. Hopefully it's spelled like this. So basically like MVC, etc. And these things are like much more worth learning than like the stupid UML and all that. And What else? What else do I think this module could be talking about such that it's better? I feel like testing is good, but it covers some testing, but it didn't really have like a lot of saying like rigorous testing standards. Yeah, and basically, I think that it should eliminate all this like UML bullshit and spend more time on actual code. And it would be really nice if we could have like analysis of some like popular uh, Java like open source projects, like open source code bases. This will help us like understand how like Java is actually done like in the like industry. How like what is the idiomatic way of writing Java as opposed to like all these like nonsense UMLs. Um, I hope that wrapped up what I've learned for this module. I mean, it's not like what I learned during this module. It's what like I learned while taking this module. It's not like what I learned from this module, but it's what I learned while taking this module, and hope it may be helpful. I don't know. Um, yeah.